We're going to pick up where we left off last class, which is on problem 7.4. In this problem, a person took some medication, but they don't remember how much they took. Fortunately, they do have the option to do a blood test and see how much medication is still in their body each hour. So we've got that data displayed here in our table. The first question we're asked is to think about this equation right here, where M is how much medicine is left in the person's body, and they want us to find the growth factor, which is B in this equation, and then also find A, the other number in the equation. So the first thing we'll find is the growth factor. Well, we've kind of been using the terminology of a decay factor because these are going down, but it works out either way. So to get from 100 down to 50, the number we are multiplying by, the factor here, is 1/2. And to get from 50 to 25, I would also have to multiply by 1/2 to do that. Now, if those numbers aren't obvious, you can always go ahead and see by doing division to go backwards. So I can do 50 divided by 100, which comes out to 1/2, and that will give you that number right there in case you can't kind of think of it in your head. So we found here, first of all, that B is 1/2. The number we are repeatedly multiplying by is 1/2. So what is A then? Well, we've seen this in equations before. This A value out front here is always our starting value, or more specifically, it's the value of our output when our input is 0. It's our y-intercept. So in this problem, that's going to be right here. 100 milligrams is going to tell us what A is. So A is 100, B is 1/2. That means that I can now go ahead and write this equation with all the numbers filled in, which is going to help me when I now want to answer the question, hey, how much medicine is there after when t is -1 and when t is -3? And then we're going to go ahead and we're going to put those in the table as well. So first of all, when t is -1, we can just use our equation to find that number. And you can throw that into your calculator or do this on Desmos, and you will see that comes out to 200 milligrams. We can do the same thing for when t is -3. Plug in -3 for that t value, and that will give us, in this case, 800. Now we kind of jumped over a value here. I just want to point out there is, t is -2 and m is 400 in the middle here, and that can be kind of helpful because that lets us see that this pattern is really continued, right? We go from 800 to 400, that's times 1/2. 400 to 200, that's times 1/2. 200 down to 100, that's times 1/2. So our pattern does hold up even as we go backwards here with these numbers. Next question asks us, hey, what does it mean when t equals 0 and t equals -3? Well, t equals 0 we've dealt with before. T equals 0 is when they first measured the amount of medicine. In a sense, it's kind of our starting point. T equals -3 is a little bit more interesting. So if we think about a positive number first, like t equals 5, that means that 5 hours have passed since they first measured. If t is negative, that means that it's actually before they measured. So t equals -3 is 3 hours before they first measured. The third problem now says that we know the medicine was taken 5 hours before that first measurement, right, when t was -5. So we want to figure out how much medication did the patient take. So all that means we're going to have to do is use our equation. M equals 100 times 1/2 with an exponent of -5. And again, you can throw that in your calculator. That will come out as 3,200 milligrams of medication when they first took it. Question 4 and 5 keep going on the same problem, but in question 4, we're going to graph these points that we found. And in question 5, we're going to use our graph to answer some questions. So first thing I want to do here is make sure that I have my axes nice and labeled with what numbers I'm going to have to use. So I know for time, I want to go from around like -3 to +3, because that's what the table roughly included. So 1, 2, 3, and -1, -2, -3. And for the amount of medicine, at -3, I have to be able to get up to 800. So I'm going to go up by 100s here. So 1, 2, 3, 4, 5, 6, 7, 800. So there's again 100, 200, and I'll just label those. Now the rest of this is just going to be that we are filling in the points here. So we had -3, 800, that's like right around there. -2, 400, it wasn't technically on the table, but I'm going to include it anyway. -1, 200, 0, 100. Now we're getting to the small numbers, 1, 50, 2, 25. And here's another point that wasn't on there, but I'm going to include it. 3, and the output there would be 12.5. So our numbers are getting real small. Now let's do one last thing here. Let's go ahead and connect the dots. Because this is continuously going down, it doesn't jump from one dot to the next. And there we go. Now we've got our graph. So based on the graph, what is going to happen here? When will the patient have 500 milligrams of medicine? Well, if I look at my graph, 500 is right up here. So I can kind of trace that over, and it hits right around there. Bring that down, and it looks like we're right around maybe -2.3 for our time, so 2 1/3 roughly hours ago, or before they first measured. And then the next one's a little bit of an interesting question. When will they have no medicine? So our graph has not actually hit the point of having no medicine yet. It's getting close. We only have 12.5 grams or milligrams. But if you think about it, the next step is going to be 6.25, then 3.125, and then it's going to keep getting smaller and smaller and smaller from there. But if I just keep cutting the value in half, one very reasonable answer here is that there will never be no medicine. And if we did the calculation out, that would pretty much come out in the equation as well, that we're always going to, no matter what I plug in for t, I'm always going to get out a very, very small number, but it won't be 0. Now, the other argument you can make here is that it will be 0 after a very, very long time. Because if we think about real life, we will eventually have none of this medication in the body. That last molecule of it will eventually go out. But mathematically, it's very easy to make either of these arguments, that there's always going to be at least a little bit, or after a very, very, very long time, we are definitely headed towards 0.